Hello and welcome to this tutorial. We are going to go over the process, the formulas of how to find the number of subnets when we subnet a classful network, and also how to find the number of valid hosts in each one of those subnets. Okay, so we've gone over these before in some of the other examples, but here we're just going to focus on these exclusively because they're both very important. So the idea is for you to walk away from this tutorial being able to use these formulas every time successfully. So speaking of the formulas, the first one, in order to determine the number of subnets, it's very simple. It's 2 to the power of the number of subnet bits in the subnet mask. Likewise, in order to find the number of valid hosts in each one of the subnets you're creating, the formula is 2 to the power of the number of host bits in the subnet mask minus 2. And we're subtracting the minus 2 at the end here, if you remember, because we have the network number that we don't assign, and we have the broadcast address, which does not get assigned to one single host. So when we say valid hosts, we really do mean the IP addresses in a subnet that we can actually allocate to endpoints, like a computer or a router. Alright, so let's run through a few examples. Okay, we're going to look at this network number, 192.168.1.0. And we're going to subnet it by applying the subnet mask 255.255.255.240. Now that's a /28 in prefix notation, and we know that because if we look at this subnet mask in binary, we can see there are 28 1 bits. Alright, so the first thing we want to do is ask ourselves a question. Namely, is this a class A, B, or C network? 192.168.1.0. Well, the answer is it's a class C network, and we know that by looking at the first octet. 192 falls within the class C network range. Now that's important because we know a class C network has a default subnet mask of 255.255.255.0, which means the first 3 octets are dedicated to the network portion. And we know in subnetting, the network portion never changes. Well, it's good to establish that because when we want to find out the number of subnets we can create with this new subnet mask, the formula requires us 2 to the power of what? Well, we know what our network bits are. We can't touch them. That means the remaining ones in the subnet mask have to be our subnet bits. So here we have 4. This equals 2 times 2 times 2 times 2, which is 16. So by using this subnet mask, we can create 16 subnets, 2 to the power of 4 subnet bits. If we move on and now look at the hosts, our formula here is 2 to the power of the number of host bits. Well, we stole 4 host bits in this to make this subnet mask, so we only have 4 left. We plug that in our formula here, and in fact it's the same as a subnet. We're going to get the same answer. 2 to the power of 4 equals 16 minus 2 equals 14. Don't forget, the minus 2, we're subtracting the network number and the broadcast number in order to find the number of valid hosts. Okay, so that's it. We've determined that by using this subnet mask, we can create 16 different subnets, and each subnet is going to have 14 valid hosts. Let's go ahead and look at another example. Here we're going to look at 150.150.0.0. That is our network number, and the subnet mask we're going to apply to it is here, 255.255.255.252, which is known in prefix notation as a /30 because we're adding up all the 1 bits in the subnet mask, and there are 30 of them. So just like we did last time, let's go ahead and ask ourselves a question. Is 150.150 a Class A Class B, or C network? The answer is going to be Class B, because 150 falls within the range of the Class B networks. That tells us that the first 2 octets are dedicated to the network portion and will not be changed. So when we go ahead and try to figure out the number of subnets we can create, we need to know the number of subnet bits. Well, the remaining subnet bits in this mask are the 1s, and we can see it is all of these. So our formula will be 2 to the power of 14, there are a lot of them this time, equals 16,384. That's a lot of subnets. We're really chopping this Class B network into a lot of different subnets. Let's go ahead and see how many hosts are going to be in each one of those subnets. So the formula there is 2 to the number of host bits. Here there aren't very many. There's only 2 left. 2 to the power of 2 equals 4, and then we subtract 2, one for the subnet number, one for the broadcast, to give us 2 valid hosts in each one of these 16,384 subnets. So here we're creating many subnets, but each one is very small. In fact, we only have 2 IPs we can actually use to assign to devices in each one of these subnets. Okay, and so that is the approach you can take in order to answer these 2 questions whenever you're looking at a classful network and you are going to apply a subnet mask to it in order to then find out how many subnets you're actually going to create and then how big each subnet is going to be. In other words, how many hosts will be in each one. Okay, well, to summarize, we really just looked at these 2 formulas, and they're very useful in order to answer the questions, how many subnets are you creating, and how many valid hosts will be in each one. So, focus on these in practice. Write out some network numbers. You can choose them randomly. Choose 1 or 2 Class A's, B's, and C's, and then choose a couple different subnet masks like we did, and then just walk through the process of each one. Determine the network bits, determine the subnet bits, and then determine the host bits. As long as you know those three pieces of information, you can use these formulas rather easily in order to answer these questions. Okay? So that is it. That is how to find the number of subnets and the number of valid hosts per subnet. Keep practicing, and thanks for watching.